Natural numbers are the smallest. Okay. Then what's the next biggest category?
Whole numbers.
Yep. Okay. Then the next one? Integers. Then the next one? Rational. Okay. Now the box over here represents your irrational. And take notice how irrational is not adjoined with all the other numbers. It's kind of separate because it's its own category. But rational and irrational numbers make up all our real numbers that we talk about. Okay? So, rational numbers. What is an example of natural numbers? 2. Okay. Yeah. No, that's natural. Remember, natural is the smallest. Natural fits into whole, fits into integers, fits into rational numbers. So 2 is all of those. So that's okay. So 2. What's the one that we usually start with? 1, right? Okay. And then 3, and then keep going. What's another name for natural numbers? Natural numbers. What? No, because we can go up to 10. What? Nope. Nope. That's the big umbrella that all of these things are under. We want a smaller category. If you think about like what we're doing here, start with 1. 1, 2, 3, 4. What? Counting. Yep. These are counting numbers. That's another name for it. Okay. What about whole numbers? Whole numbers are just barely different than natural numbers, but they have one number that natural numbers do not. What's that number?
1.
Nope. 1 has it's in natural, right?
0.
0. Okay? So whole numbers are just the natural numbers with 0. Okay? Okay? We still have 0, 1, 2, ... 3, 4, 5, 6. Okay? Now the reason why those are separate is because natural numbers are just describing all positive whole numbers, just your positive integers. Okay? 0 is not included in natural numbers is because it's not positive. So it's like its own category since it's nothing. Okay? So that's why they made a distinction between natural and whole. Okay? What about integers? What's special about that?
Positive and negative.
Positive and negative, what?
Numbers.
What kind of numbers?
Counting.
Whole numbers, there you go. Now just remember, 0 cannot be positive nor negative, but it's in the whole numbers. So you could say with 0. So we have -2, -1, 0, 1, 2, ... And so we can go on both directions forever. Okay? Now rational numbers and irrational numbers, their distinction's a little harder to figure out. So what's special about those two? No, from rational and irrational. And maybe it's easier to start with irrational. Does anybody know what irrational numbers are?
Negative numbers that are not.
Okay. There's a start. So they're not whole numbers. Well, they're not just whole numbers. They're not whole numbers at all. Yeah? Okay. So decimals that can't be turned into fractions. Let's put that together. Okay, so no fractions. But what are those? What's special about those decimals? They are decimals.
They can be whole. They can be positive or negative.
They can be, but that's not the distinction. Irrational. So it said no fractions. So what's special about fractions? If I wanted to change a decimal to a fraction, what would it need to have? What? Division. Okay. Yeah. What else?
Whole numbers in it. Two whole numbers divided.
If you wanted to change a decimal into a fraction,
Mm-hmm.
you would have to.
What would the decimal? Yeah, what does a decimal need to be able to be turned into a fraction?
It needs a whole number.
It needs a whole number? What do you mean?
No. So, let's say point.
0.25.
You have to divide. You have to divide it by a number.
Okay. But what's special about 1.25? Okay, so that's rational. It's a decimal. It could be a fraction. Okay. Decimals. Special. What do we know about decimals? What can decimals do? Can I? Okay. You keep going back to that whole number thing. No. Get away from it. Say what? Yes, but what does a decimal need to be able to be turned into a fraction? There are two properties a fraction or a decimal would have. What? No. Two properties. Or maybe this will help. If I give you an irrational number, like pi. Pi is irrational. Okay? What's special about pi?
It goes on forever.
Goes on forever. There you go. Say what? That was what he said? Okay. So that goes on forever. And what else does pi... No, that's the same thing as going on forever. Okay. What else does pi do? We don't need to know what pi is. You know what it is. But what's special about those decimals? So it never stops and it doesn't what? What, Mohammed? Repeats. There you go. It doesn't repeat. Okay, so if a irrational number's decimal does not end, nor does it repeat, rational numbers, they repeat and they end. Good. Okay, that's usually called a decimal with a number that terminates a decimal, or a decimal that terminates, stops. Okay, so let's fill in these a little bit more. So you know what, we already had some natural numbers like 1, 2. The special one for whole is 0, but it also envelops those other ones. Integers are going to be your negative numbers. What's some examples of rational numbers?
1.25.
1.25. What else?
2.5.
2.5. Let's say is negative 2.5 a rational number?
Yeah.
Yeah, because it can be negative 2 because it's an integer, right? Okay, that's good. What about irrational numbers?
0.666 repeating.
Nope, that's rational.
I mean,
Because that one,
did you say rational or
irrational.
irrational? Oh,
3.14.
Just say 1.
There you got pi. 3.14 stops.
Say 6 repeated.
So that repeats, right?
Because irrational is repeating.
no, after
Irrational doesn't end and doesn't repeat. Now these are maybe numbers that you haven't seen before. One of them we talked about that stands for a variable, or could be stood for a variable, but we're not going to use. Remember what that is? No, T is not a number.
A number?
E. Oh, I just gave it to you. E. I was going to say something else. E is an irrational number because it stands for like 2.17 something or other. Keeps going on, kind of like pi does. Doesn't repeat. Doesn't end. No. That's the only one that does that is E. Okay? So, stop guessing. No. So, another one that you'll see like later on, probably not in Algebra 1, but is square roots. So square roots that don't simplify down to nice, pretty numbers. It's like square root of 2, square root of 3, square root of 5. Those numbers can't be written as a fraction, and those decimals don't repeat.
What are you recording?
This lesson? Okay.